First of all, there is a conveyor. On the conveyor is installed the gear clock, the part detect and the imager. The competing stuff is somewhere else and it is connected via link. In each case, the gear clock is connected with the imager and also the trigger or part detect is connected to the imager. The parts are coming from here and move through the trigger, and then under the imager inside the software there is a countdown from the ticks of the gear clock from the beginning of the rising or falling edge. This is a setup. From here to the middle of the imager. And then a flash of the LEDs, which are here inside, occur when the part is arriving in the part of the imager. The other devices rejector are just behind the imager. And the part will be counted down from here to here. This is a distance in gear clocks saying from here to here. We will count this gear clock from this device. If you ever had problems with the image taken from the camera inside, you first have to check the shaft of the gear clock or maybe the trigger, which is not correctly mounted. And the last device is the reject surveillance. This is also counted by gear clocks, but you also need to set up the length of the object to make sure that you really check for objects and not for anything else on the belt. So everything works together and everything is depending on the gear clock here. You can see this is the inside of the imager. This is the camera. We have an ultra-compact system here. So this is the computing stuff, everything you need. This device here, this PCB, is the RTS. You can call that RTS real-time system. So if everything works correctly and you press the button illumination, you will have some light groups here. Maybe this menu looks different to other softwares, but it is still the same function. So at the moment we record here an image in 3:1. So you can see the LEDs are flickering in high frequency. During the flash, the image will be taken so it looks like a live video. But if you stop, you have one picture shot freezed and you can take this image to the store. And if you go by live again, the flash is switched on again. So again, you see it is a real live image and you can play now with the illumination values. And you see the inner group, that is this first group here, and the inner group doesn't bring a big effect because there are only a few numbers of LEDs. But if you go more and more, you can increase the illumination very quickly and then you have a proper illuminated image. You can measure that here. That is a contrast from 0 to 100%. That is the mark where you have the midpoint here in pixels. You can play around with the pulse width. It gets brighter and brighter if you have a longer pulse width. And a short pulse width will tune the image darker and darker. So that's shutter time. It is not the shutter time of the camera. The camera shutter time is the longest time what the camera can make. But the shutter time here, the pulse width, is the length of the pulse of the illumination, and in each pulse is the strobe with the value rated here. So you can set each LED ring in the value by these small fields here. So 0 means it's off, 100 means it is completely on. But it is always strobe because then the LEDs can live longer when they are continuously on. Some lot systems from Ibea have a color camera like this because you can see this is a Carreau Rouge twist of cap with a massive defect on the curl which you cannot really see in the color picture. But you can see it very clearly in the black and white picture. We have a color mixer here, so you can tune the RGB. Now you see if you have a big green and a big blue inside, you have a black and white from these Carreau Rouge decors, which is similar to the defects. So you give an information to the operator by the color mixer. You have to tune the red into more and the green and blue to off. And then you see you have a more or less picture without any decor inside, but you see easily the defects on the curl. It can happen that some neighbor objects are coming inside the picture, and to make a proper centering, we can do an isolation of these objects in horizontal or vertical way with this red box. The yellow box or the green box, this is the result of the contrast of the threshold here, and you see if you go too low, there is no centering, no object isolation. But if you go with a higher contrast or higher threshold, the green box will stop here, left, right and bottom. Only 4 points, only 4 lines. This is just a raw centering of the device. It is helpful to have the color mixer as well here for the object separation, because then the decor is not the result of the separation. You have to allow the object separation a little place with the reserve width, so that gives the following centering a little bit more playground to sneak around where the object is. For here we have the color mixer, but it's not so important. We can center also from the inside to the outside. In this case we go from outside, and it's the same like the object separation, but now with a round circle. If you tune the threshold higher, then the circle gets tighter and tighter to the curl and will stop other contrast. We have a contrast here from 51%, so if you go to the half of it, let's say 26%, then you'll have a proper centering. This centering will give you the middle of this device from the outside. It has nothing to do with the lux centering, or it has nothing to do with the bottom centering or seam centering. Now we have the midpoint, and now we can start to add so-called scans or regions of interests. This is now done by a circle. What you see here is a histogram. A histogram is a number of pixels by the contrast or grayscale you can see here. So 0 is dark and 100% is bright white. So this gray from the panel comes from the illumination and you can see here there is a little black or darker area. It must be something like this here. Now you can see the feet of the histogram is very small. And that is exactly what you need. A small feed for having our values here and here to allow this device to have a histogram inside the limits. Left, that means here, or right, here. But you can see if you go with a scan or region of interest more to the dirt, you'll see the change of the histogram when you're looking at the feet. Inside the teach-in, you have the same region of interest and the same histogram, but now you can set limits. You can see the minimum limit together with a low number of pixels or maximum limit together with a high number of pixels. If you go to the minimum limit, you can change the border. The vision system is very simple. The device, this cap, is okay in this area. If the histogram is in between the borders or the number of pixels darker or brighter, outside the borders do not have the amount from low and high here. If you go and tune this to the dirt, you can see the failure here in the histogram. And in the teach-in, you can set now the border exactly to here, and you can see now 5 low pixels. Allowed is only 0, so this will happen to reject then. If you go here with a low higher than 5, you will see it will turn from green to red. This is the size of your fault. This is the contrast of your fault. Minimum and low, maximum and high becomes together. Don't forget to switch on the reject one. Maybe you go with high reject indicator. This is the standard regular mode, the standard vision.